All right, so we have iClicker going, so everybody should check in on iClicker. So make sure you go ahead and do that. And we're gonna always do that, but at the same time, what we're being asked to do is to make sure that every day we have a correct seating chart for everybody. So remember what we did on the first day, how we typed into the seating chart, right? I want you to go and do it again, and we're going to do this every day. So go to Moodle, under course information, go to 4T seating chart. So everybody should be doing this, whether you come in early, come in late, doesn't matter. If you are present in the classroom, you need to put your name in there. If you are on Zoom and you are at home only, put your name right down here in one of these squares, these yellow squares. Remember, your name only goes in a yellow square. I'll give y'all just a minute. Make sure that once you type in your name, you hit enter and you leave that, what's that? You're on view only. Let's see. Let's see. Of course, we have to have two-step verifications. How does it know my phone is with me is what I want to know. Yes. Okay. So this one should be anyone with the link can edit. Okay, try again. Oh, I see people typing. So we must be successful, yes? So remember to, once you type in your name, press enter or click on a cell outside of the cell you're typing in. Everybody put your masks over your mouths and over your noses. Everybody. Okay. Everybody getting it? I should see everyone's name on this before we move on to the next thing. And if you come in late, when you sit down, make sure you do it. So it might not be up by the time you walk in the door, but for contact tracing purposes, we have to know. So everyone's name has to be on this every day. How are your other professors doing this? This is crazy. I don't know. Just trying to do what I'm told, right? Okay, so I'll start out with a joke, as always, right? Good quality ones. So what is orange and sounds like a parrot? A carrot. I kind of liked that one. I don't know why, but I kind of liked that one. All right, let's see. I have one more because it's taken us a minute to enter these. I always have a plethora of them, unfortunately. Who stole the soap from the bathtub? The robber ducky. The carrot, I like the carrot one better, but that one wasn't too bad. Okay, so make sure that you're doing the 4T seating chart and not the 5T. Make sure you're doing 4T. Okay, anybody have problems? Can't do it? Anybody? What happened? The what? Try a different Wi-Fi. There are 2 different Wi-Fis in this building. Nope. Can you do it on your phone? It's not letting you type your name while you're on your phone. Oh my gosh. Send me an email that has your seat number. Say today is 24, my seat number is 3D, whatever it is, okay? Y'all heard that? If anybody can't type it in, send me an email with your seat number, okay? Or maybe ask your neighbor to type it in if they're having an easy time. Okay. So while we have this up, remember your class calendar, what's due next? Mini homework B, and then homework 1, chapter 1, right? Mini homework B is your profile picture and the form. And then homework 1, chapter 1 is on the Pearson site. You have to go through course materials to get there. Yes, ma'am. No? Okay. All right. Close that. We'll close that. So we're looking at 56 people. All right. So y'all ready to do some eye clicker? Ready? Get your eye clickers out. Remember, the first time I ask you, it is just you. It is no one else. Y'all ready? Okay. Full screen. Okay. What I want you to do is I want you to look at our measuring device. Move this around. And I want you to identify the number of significant figures that you should report this measurement. This is what you're going to do, right? You're going to have to write in somebody's chart. I gave this person so much of a dose, right? How do you know what to write to? What's our rule for significant figures? I'll give you this hint. What's the rule on any measuring device? Okay, let me rephrase that. I will allow someone to share the answer to that question. I'm not going to give it to you. It was in the lecture. How do I know, just looking at a ruler, how many significant figures to report to? Anybody? Take a guess. I'm offering to help y'all, yes. Very close, very, very close. So you're looking at the tick marks, right? We're looking at the tick marks, and I've labeled them here for you. Do you just record the tick marks that you see? Oh, somebody on chat might. Oh, I'm sorry. Try closing the app and then opening it and restarting it. It has to do with the tick marks. So when you look at any measurement, the tick marks that you see, you can tell for sure, right? This is at least 1.52 meters, right? But then that measurement can go in between the smallest two tick marks. And so you actually have to estimate that. So the number of significant figures should be however many you can for sure see, and then you estimate 1, right? Because if it's in between the two tick marks, what would you estimate that as? 0.5, right? It'd be halfway, okay? So look at this measurement, and you don't have a dose in there, but I want to know how many significant figures you should round to. Okay, so let me start a new one. Take your best guess, and remember, you'll be able to talk to your partners in just a minute. Okay, and Jada, it just should have changed. Good, good. Show them it's recording. All right, remember I'm closing it at 1 minute. So that gives you about 10 seconds left. Don't leave it blank. Okay. So I want you to turn and talk to your partners, talk to your friends, talk to your neighbors, and answer again. I'll give you 1 minute. Make sure you cover your mouth and nose while you are speaking to your neighbors. Okay, 10 seconds. Make sure you click in for a second time. There's a bunch of people who have not clicked in. Guys, come on, we were in the 50s. Come on, I'm gonna give you till 1 minute, 10 seconds. Don't forget to click in on that second time, okay? All right, so what did we say? Okay, so we're split between A and B, right? We're split between A and B. So how do I do this? How do I identify it? Well, if I look at the tick marks, the big tick mark is what? To the what's place? Whoop. What place? The 10th, the tenths. So 1 place past the decimal, right? The smaller tick marks are what? To the hundredths. So if I'm going to report this, I'm going to report it to the what place? Thousandths. So the number of places past the decimal that the syringe measurement should be reported is 3, right? So if I had something that was maybe right about here, what would I label that as? We got 0.1, right? We're filling this syringe all the way to this point. So we got 0.1. Then this tick mark would be 0.05, right? So this would be a 5. And then I'm maybe a little more than halfway. So 6, right? Yeah. Okay, so then I have 3 significant figures there. Because it's not 1/6. It's not right on the line. It's actually in between the 0.05 and the 0.06, because it's right in between the two. So that's my estimation. So these two are known, and then this one is my estimate. You will always have one estimate. Yeah? Okay, let's try another one. All right, so now, I'm giving you one that you have to read. You ready? Okay, you read the syringe and you tell me, this is a, I forgot, wait, stop. This is supposed to be a short answer, but not a short answer, a numeric. Okay. So you actually have to type in, what should I record on my medication log if I'm giving my patient this dosage? What do I write? I thought those could do numeric. Okay, I won't count this one. I'll go back and I won't count this one. Write it down on a sheet of paper. I thought the handheld clickers could, but apparently not. So I won't count this one, but write it down on a sheet of paper. Take a guess. I'll write myself that note. Okay, 5 seconds. You don't have to do this one, but at least write it down. Okay, talk to your partners. Talk to your partners. I'll give y'all another minute, and I won't count either one of these. So write it down, what you think it is, or put it into iClicker if you can. I think I didn't go back and grade the first ones. I think I have to go back and do that. All right, put in any response. Y'all ready? Okay, so what did we say? Oh, we got a lot of variation there. Okay, so we're going this way, right? So we're trying to find the biggest. Here's my tick mark where it went to the biggest tick mark. The next tick mark is over here. So the volume is not that much. So we know we're 0.3 something, right? We go to 0.5. Is it more or less? It's more. Okay, so 0.6. Do we have more? A little bit more. What if we go to 0.7? Yeah, I would say no. I would say no. So 0.36. Now we have to estimate our last digit. So maybe 8, 9, something like that. You know, I would even really accept that one. Any of those three I would actually accept, because I would say it's a little less because of the domed part of the plunger, but I would accept any of these. Okay, good. Make sense? Okay, let me go back and I need to grade this one. It was B, right? Was it B? Let me go back. It was C? Oh, it was C. Okay, so it was C. Oh, we had less people. What happened? We had less people get that one right. That's not good. All right, let's try this again. Let's try this again. Okay, so now I'm giving you a thermometer. I want to know the number of significant figures in our thermometer. If you can't see that, it's 101.8 degrees Fahrenheit. Okay, that's what the screen reads. Oh, I put it on numeric again? No, I don't want you to do that. I'm gonna have to go back and fix this so much. Multiple choice. Thank y'all. I'll go back and clean it up. Don't worry. Remember, 1 minute. Oh, not coming from. Ooh, I think everybody answered that one quickly. So I'm going to give you 30 seconds on the next to talk to your neighbors, because I think we got this one. We'll see. So 10 seconds. Everybody enter something. Okay, so we're going to go again, but this time talk to your neighbor. So go 30 seconds, 30 seconds. Don't forget to check in again. 10 seconds to go. Click in. Everybody should click in. Okay. I think it was 54. Was it 54? Oh, 55. There, we got it. The last person got in. All right. So what did we say? Whoa, that's question. That's not the right question. Here we go. All right. So D is correct. D is correct. So when we look at that 101.8, right? It's reading 101.8. if we have a digital measuring device, do we have an estimate? There's no estimate on a digital device. So that makes it really easy. So now all you do is you look at the number. If it's 101, hello, 101.8, right? That's supposed to be a 1. Decimal present or absent? Present. So I come in from that side. I stop at my first non-zero and I count everything else. So I count 4, right? So y'all got it on that one. 91%, that's great. Oh wait, that was the first go round, 98%. All right, awesome. Okay, so let's go back to our ICP. Let's do some more problems. I call it the ICP, in-class problems. I call it that. So if you're like, what is she talking about? Okay, where were we? And I think, I wanted to say this. I think on 1.42, I think we did the division wrong. What was our final answer for 1.42? What was it? It shouldn't be 14. So if we did our calculation right, it was degrees Fahrenheit minus 32. I think we did some kind of division wrong. 1 degree C over 1.8 degrees F, right? Okay. And when we subtracted, we did negative 112 minus 32. What did we get? What? Negative 144 degrees F, right? Okay, so now we take that and we go negative 144 times 1 degree Celsius over 1.8 degrees Fahrenheit, right? So what is 144 divided by 1.8? Put it in your calculators. What is it? But don't forget the negative, so it should be negative 80 degrees Celsius. That's not what we got last time, was it?
No, we got like
I think it was a multiply. I think somebody multiplied it instead of divided it. Because I was looking at it and I was like, that's not right. Okay, so now that we have 180, we have minus 80. Now we have to convert from Celsius to Kelvin. And to do that, Kelvin is equal to our degrees Celsius plus what? 273. So what might have happened, y'all do know that when you multiply by a fraction, basically what you can do is you can remove the parentheses. So that's like 144 times 1 divided by 1.8, right? These two things are the same. This and this. Y'all okay with that math? Yeah? Yes? No? Okay. All right. So then Kelvin is equal to negative 80 plus 273. What do you get? 193. 193. And that should be Kelvin. Okay. I could go up, but I can't. Ooh. Okay, good. And that's the last one we ended on, wasn't it? All right. Okay. Ooh. So the next thing we have to talk about, oh, I did not want to really get rid of that. Here. Okay. Are the different kinds of energy, right? What are the different kinds of energy in general? Kinetic. So kinetic, when you think of kinetic, what are you thinking of? Movement. What else? Potential energy. So that's something about ready to start moving, right? And what else? Those are kind of physics terms, right? So what's an equivalent chemistry, biology term? Chemical energy, right? What is chemical energy? If I have a hamburger for lunch, my hamburger has some potential chemical energy inside of it, right? Because if I eat it, then I can go and do something. I'll have energy, right? So chemical energy is another kind of energy. And it's similar to potential energy in physics. Okay, so now we got to go back to like physics energy terms. Discuss the differences in types of energy present as a child climbs to the top of the slide, stands at the top, and slides down. Okay, so that's 3 different conditions. They're climbing, they're at the top, and they're sliding down. SL, whoa. And they're sliding. Okay, so what do we got? What about when they're climbing? What is it? Kinetic. But what happens the higher they get in the climb? Like if you climb 1 rung of a ladder, do you have a lot of potential energy or a little? A little, but if we climb 10 rungs, what happens to our potential energy? We have more potential energy. So in the climb itself, you're converting kinetic energy into what? Potential. Right? Now, when we're at the top, what do we have? We have all potential energy. I don't know how I just did that. Okay. Now, when we're sliding down, what do we have? All what? We're in motion. Kinetic. All of our potential energy is being converted into kinetic energy. We're moving, right? Yeah? Okay. All right. So now, when we talk about that hamburger that we ate, right? That hamburger had a store of chemical energy. How in chemistry do we define that store of chemical energy? What do we call that? If you see it on all kinds of nutritional labels, calories, those are calories. Okay, I have bad news for you. There are 2 different kinds of calories. All right, in chemistry, we call a calorie 1 calorie, and it's the little c calorie. Little c calorie. We define that as an amount of energy. Right? We said there was chemical energy. So the unit for energy that we use is joules. 4.184 joules. J-O-U. Hello. J-O-U. Joules of energy, right? But when you pick up that nutritional label and you see calories, it's not that calorie. I know it gets confusing. So 1,000 of these chemistry calories is equal to 1 nutritional big C calorie. So this is nutritional. It's big C, little c. Little c is chemistry, big C is nutrition. Why they had to do that, I don't really know, but it just is. Okay, so in the question, we have a moderate walk that burns 225 big C calories. Those are nutritional. See how that is a capital C? Per hour. Calculate the number of joules burned by this activity. So what am I asked to do? What is this question really asking me to do? Convert units. That's all this question is saying, is a unit conversion. So what am I starting with? And I'm going to say a big C calorie. I'm just going to put a big C calories. But I have a little more piece of information, right? It's 225 calories per hour. So I got to draw a line per 1 hour. I want to calculate the number of joules burned by this activity. Can I convert straight from big C to joules? No. So this is going to be our first multi-step conversion, right? So fence posts, right? Just think fence posts. What do I want to get rid of? The big C or the hours? The big C. So I'm going to put the big C on the bottom, and I'm trying to get to joules, but I can't get to joules, right? What relationship do I know though? I know the relationship between big C and little c, right? So I know that I can convert to calories, right? Little c calories. I know that there are 1,000 chemistry calories in 1 nutritional calorie. Okay, now, do I want to stay in calories? No, right? I got rid of these big C's, but I'm still stuck in calories. I'm stuck in chemistry calories. So I want to put my chemistry calories at the bottom. And what am I trying to get to? Joules. So do I have that relationship between joules and calories? Yeah, I have it right here. So I know that I have 1 calorie in 4.184 joules. Okay, so how do I put this into my calculator, right? I want to check my calories canceled. I'm left in joules per hour, which is what I want to be. It's just multiply the top. There's nothing at the bottom. So, but be careful when you're doing this in your calculator, that if you have something in the denominator, that you multiply everything in the top, then divide by the product of everything at the bottom. And we'll do some examples of that. So multiply everything at the top. What do you get? What? 941,000 joules. Joules, right? That's a comma. 400. Oh, sorry. 400. Like that. If I could write a 4 to not look like a 9, right? Okay. Are my significant figures correct? How many significant figures can my answer have? No more than the original values that I started with. How many did I start with? 3. How many can my final answer be? 3. Is my answer correct? No. What do I need to do? Change the 4 to a what? So what should my answer be? 1,000. Why isn't it 94,000? Like, you have to make sure that if you convert that 4 to a 0, you keep it in the right place, right? Okay. And it should be the same units, joules. Oh, I'll just put a J. Good. All right. Okay. Now this kind of backtracks to what we were talking about last time, which has a higher specific heat, water or salt water. So when we talk about specific heat, the thing that changes the amount of heat that a substance can absorb has to do with the amount of stuff dissolved inside of it, right? Water is a wonderful insulator. We know that because our bodies are made out of mostly water, right? And if you don't want your car to overheat, what do you put in the radiator? Water. But we don't just put water. A lot of times we buy radiator fluid, right? What's the difference between water and radiator fluid? What? The specific heat. Why? Why is the specific heat different? That's right. It's got stuff in it. We dissolve stuff, ions and different compounds inside of our radiator fluid. And so the more stuff you have in there, the harder it is to boil your water. Like if you had a pot of water and you put salt into it, you've heard this before, right? You're making pasta and people put salt in their pasta, right? What does that do? Changes the flavor, but what else? It changes the specific heat capacity. So what happens is it takes a higher temperature to boil the same amount of water if you add salt to it. So your pasta will boil, but instead of boiling at 100 degrees, it boils at 102 degrees, right? So it doesn't make your pasta boil faster. It makes your pasta boil at a higher temperature, right? Okay, so which has a higher specific heat, water or salt water? Salt water, why? Because there are, we'll just say substances, and this is salt, in the water, right? So it prevents those water molecules from transitioning from the liquid state to the gaseous state. So basically those water molecules bump into salt, and instead of going out into the vapor phase, they just stay as a liquid. So you got to increase that temperature so that when they bump into the salt, they still escape. It's kind of weird, but it's interesting. Okay. But your textbook has tables, and so if I ask you something like that, I'd give you a table, right? Okay. Indicate if the following describes a solid, a liquid, or a gas. Ooh, these should be easy, right? This state of matter has a definite volume, but takes the shape of its container. That's a liquid, right? That's a liquid. If I had a big pot of water, right, and I poured it into a fish tank, it wouldn't take up very much space in the fish tank, right? Because it's taking up the shape of the new container. The particles in this state of matter are so far apart, they do not interact with one another. That's a gas. That is a gas. Good. Very good. Okay. Now, measuring matter. When we measure matter, the two things that we use to describe our measurements are accuracy and precision, right? So a lot of times we think about a target in terms of accuracy and precision. So precision is what? What's the difference? See, close, that's good. Close to true, we're going to say true value, right? Whatever that true value is. Yes, that's true. So what is precision? You get the same answer every time. Doesn't matter if it's accurate or not, but you get the same measurement every time. So multiple measurements are close together, right? So let's look at some data, right? So we measured some volumes with a graduated cylinder, and we measured some volumes with a beaker. If you're in the lab, what do you want to use? If I want to know how much volume I have, been in the lab before, what do you want to use? Graduated cylinder or beaker? Just a graduated cylinder. Why? You have more of those tick marks. You have more of those tick marks so that you can get a more accurate volume measurement, right? Because that's what we saw with that syringe. The closer the tick marks were together, the more accurate we could get. Okay, so let's see if the data supports that. Which set of measurements is more precise? Graduated cylinder or beaker? Precise, because we said precise is multiple measurements close together. So the biggest deviation is what? Deviation. Between 9.5 and 10.5. So that's 1 mil, right? This varies by 1 mil. How about my beaker measurements? What do they vary by? What's the difference between those? 4 mils. I just looked at the difference between the biggest and the smallest. So I don't have a whole lot of variation in my graduated cylinder, but I have quite a bit in my beaker, right? So which set of measurements is more precise? The graduated graduated cylinder, right? Which set of measurements is more accurate? Oh, absolutely, the graduated cylinder. How did you know that? Each individual measurement is close to the true value. How close is 8 to our known volume of 10 mils? Yeah, not very close, right? That's really far off. But the farthest one in here is what? So this is the farthest one in our beaker. Where's the farthest one in our graduated cylinder? Either 9.5 or 10.5, but you're only 0.5 away, right? So if I took the average, what's my average? 10, right? What's my average here? 10. They're both 10. So you can't just take an average of your values and say, hey, the beaker's great. The beaker's not great. The beaker's really not great. The graduated cylinder is, okay? So which measuring device for volume is more accurate? Graduated, why do I not want to spell it right? We're just doing GRAD, graduated cylinder, right? Everybody wants a graduated cylinder. Just don't drop them, right? Okay. All right. So now we're going to get a bit more complicated. We're going to do some more dimensional analysis, but this is super, super, super close to what you're going to use and what you're going to do on a daily basis. This is dosage calculations. If you are a nurse, if you are doing things in the medical field, you will have to calculate dosages. Okay, so this is as practical gets for this class. So a mother is to give her child 10 cc's of medicine every 6 hours, but she lost the syringe that was provided with the liquid medicine. Been there, done that. She calls your clinic for help. How much medicine in teaspoons can you instruct to give the child per dose and per day? What are we going to do here? What kind of a problem is this? It's dimensional analysis. It's fence posts. All it is fence posts. Okay? So you start with what you know. What do we know? 10 cc's per what? Per 6 hours, but she wants to know per dose. So 6 hours is the same thing as one dose, right? Right? In the medical terms, that's what a dose is. However much you give a person per time. Okay. So this is 10 cc's per dose, right? Okay. But she doesn't have a syringe, so she can't measure cc's. So you're going to have to give her a conversion. Anybody know what the conversion is? 5 cc's. This one you should probably know. Will help you in the future. So 5 cc's is 1 teaspoon. What's that? All right. So put my fence post up. What do I want to do? Do I want to stay in cc's? No. So I'm going to put cc's on the bottom, and I'm going to put teaspoons on the top. So I know that for every 5 teaspoons, for every 5 cc's, I have 1 teaspoon. So what does that give me? My cc's cancel. So I'm given 2 teaspoons per dose. Did I answer the first part of the question? Yeah, absolutely. Absolutely. So I'm going to box it in just so we know that this is an answer, right? So this is our answer to per dose. But we still have to answer something else. Maybe she spilled some of it and she wants to know if she has enough to get her through before the pharmacy opens tomorrow, right? That's kind of something important to know. So how much per day does this child need? So teaspoons is okay because that's the way mom's going to measure it. Now we want to change dose into what? Dose into day. We want to change dose into day. So if I want to get rid of dose, I'm going to put my fence post up. Where does dose go? No, what is this? Your next. Okay. So dose is going to go on the top. Come on. Dose goes on the top. What goes on the bottom? Can I go from dose to days? I got to go to hours. Oh, very nice. I got to go to hours because I know that in one dose, there are 6 hours. Did I answer the question? No, so I'm going to keep my dimensional analysis going. I want to get rid of hours. So where does hours go? At the top. What goes at the bottom? Days. How many hours per day? 24 hours in one day. So let's check to see what cancels. So my hours cancel, my doses cancel. I'm left with what? Teaspoons per day. So you have to do 2 times 24, get an answer, and then divide that by 6. Right? So what do you get? 8 teaspoons per day. I'm going to box it in. Good. Okay. All right, here's another one. This gets a little more complicated. A 38-pound child is prescribed medication for chicken pox in the amount of 80 milligrams per kilogram of body weight per day to be divided into 4 doses. Like there can't be more information in one sentence than that. Each tablet contains 700 milligrams of the medicine. How many tablets should be given per day per dose? You have to be able to do this. This is real life. Okay. So we have a 38-pound child, but the medication is given in milligrams per kilogram of body weight. So what does that tell me right off the bat? I'm going to have to convert. So I want you to be looking at these problems and realize I'm going to have to be doing some conversions, right? Okay. So I'm told, what's my dosage? What do I want to give the child? 80 milligrams per kilogram of body weight. So 80 milligrams per kilogram of body weight per day. Right? So I kind of have 2 things going on. Right? You with me so far? So we just have something in the numerator that has 2 units. Okay. All right. So let's kind of do the top first. I want to give him 80 milligrams per kilogram, but I need to know how much to give this kid, right? Because I don't want to give a child too much medicine, right? Children are very small. So if you get that dosage wrong, that can be very, very dangerous. So I'm going to convert my milligrams per kilogram into however much I want to give this child. So I want to get rid of kilograms and I want to introduce what? Pounds. So how do I get rid of kilograms? Put it on top, and then I'm going to put pounds on the bottom. Do I have a conversion between kilograms and pounds? You look on your best friend sheet. There should be one, right? Make friends with that sheet. What do you find? 2.2 pounds is equal to 1 kilogram. Okay, so the pounds goes on the bottom, 2.2, and I have 1 kilogram on top. So now I've converted, gotten rid of my kilograms, I've converted to milligrams per pound. But how much does my child weigh? 38 pounds. So multiply that times 38 pounds. What happens to pounds? They cancel. What am I left with on the top of this whole big long thing? I'm left with milligrams. So I get milligrams per day, right? So do that. 80 times 38, press enter, then divide by 2.2. What do you get? What do you get? Y'all got to hear those calculators. If you're not doing the calculations with me, when you get to homework, it's going to be a problem. There's still some stuff to do. There's still some stuff to do. I kind of just wanted to simplify that. Okay, so the question is, how many tablets should be given per day and how many per dose? Well, I'm in milligrams per day. I want to be in tablets per day. Can I convert that? Because I know each tablet contains, so 1 tablet is equal to what? 700 milligrams. Sometimes it's nice to read the problem and take those numbers out and make them equivalents. Do you see how I did that here? I did it here. Do that. It will help you. Okay, so now I just want to extend my fence post, right? And I'm going to put milligrams on the bottom because I want to get rid of it. And I'm going to put tablet on top. So then what? So I know I have 700 milligrams in 1 tablet. So now it's 1,381 divided by 70, and I get okay. Well, so okay, you tell me. What's my lowest number of significant figures? 38 is how many? 38 is how many? 2. 80 is how many? 1. 700 is how many? 1. What should I give it in? 1. So really that should be 2 tablets per day. And that makes sense, right? Would you prescribe to a child 1.97 tablets per day? No, you wouldn't do that, right? Okay.
So it's for significant figures, it's when you multiply and divide, it's your least, and when you add and subtract, it's
The least number past the decimal point.
okay.
Yep. Mhm. Okay, now, how many tablets should be given per dose? I need another equivalent relationship. Read the problem. What's my other equivalent relationship? 4 doses, what? Is equal to? Per day. So 4 doses in 1 day. So if I have days on the bottom, what am I going to do? I want days on the top. 1 day, 4 doses. My days cancel. I end with tablets per dose. How many? Two divided by 4. 1/2, 0.5, right? Can you cut a tablet in half? Sure, absolutely. Absolutely. Make sense? I'm telling you, you will see one like this on the exam. up front, telling you, you're going to see one like this on the exam. You have to be able to do this. Okay. All right, let's try another one. It's a good thing I gave you a couple like this, right? Okay, a child must take 10 milliliters of, I just say a medicine because it doesn't really matter what it is. It's an antibiotic by mouth 2 times a day for 10 days. The solution is provided as a 50 milligram per milliliter suspension. How many milligrams will the child have taken when the course of medication is over? Okay, what do we want to start out with? So they're going to take 10 milliliters. Okay, we could start with that. What's next? Do we need to put something on the bottom? Not always. Sometimes you just have something in the numerator, and that's okay. All right, I'm trying to get to what? What's my goal? Total milligrams. My goal is total milligrams. So I have to convert from milliliters to milligrams, right? Okay, so what do I do next? How many times are they taking 10 milliliters? 2 times a day. So they're taking it 2 times per 1 day, right? For how many days? For 10 days. What's happening to my units? My days cancel, right? Okay, now what? What other piece of information do I know? As a 50 milligram per milliliter. When I put this into my dimensional analysis, that's just like saying 50 milligrams is equal to 1 milliliter. It's the same thing. So where do I want that 50 milligrams? The top or the bottom? At the top, 50 milligrams, because I want my milliliters to cancel out. And the only way my milliliters will cancel out, right? If milliliters were on the top, now milliliters are on the bottom. Okay. So 10 times 2 times 10 times 50. What do you get? 10,000 milligrams in the total treatment. Right? Sometimes that's really important in medicine, because if you give someone too much of a particular medicine, it can have like liver damage or kidney damage or something like that. So you kind of have to keep track of how much you are dosing someone over time, right? So much of this medication in a 1 month period can lead to liver toxicity. So how do you know how much you're giving your patient? You have to calculate it. Okay. Did I not do 1.59 in the video? Did I just skip it? I guess I did. It's crazy me. All right. A patient gets 2 liters of fluid over 18 hours through an IV. The drop factor, right? You know, in an IV, if you've seen it, it drips at a particular rate, right? Okay, so that's the drop factor. And the drop factor is given in GTT per milliliter. That's like drops per amount of time, right? So calculate the drip rate in drops per minute. I want GTT per minute. So what kind of a relationship do I have to start out with? What do I know? The patient's getting what? 2 liters of fluid over 18 hours. Okay. Our drop factor is 20 drops per milliliter. I want to get rid of liters. So I put liter on the bottom, but now I need to do a conversion from liters to milliliters. That's right. So go to your best friend. There are 1,000 milliliters in 1 liter. Okay. Now I want to get rid of liters. I'm sorry, I got rid of liters. I want to get rid of milliliters. So I put milliliters on the bottom. What do I put on the top? Using this little conversion right here. So I know 20 GTT is equal to 1 milliliter. So I put GTT on the top. There are 20 GTT in 1 milliliter. Right? Okay, so I got rid of milliliters, but what was my goal? GTT per minute. It's important to know what your goal is, because some people just stop, right? So don't do that. Make sure you know what your goal is. Okay, so I want GTT per minute. So now I have 18 hours at the bottom, so I need hours at the top. What am I going to put at the bottom? Minutes, because I know in 1 hour there are 60 minutes. So that makes my hours cancel, and I'm left in GTT per minute. So now be careful when you put this into your calculator. If you have a scientific calculator, you can put it in parentheses. You could do this 2 times 20, right? And then a slash, which is divided by 18 times 60. If you have a TI, a big TI, you could do that. But if you have the $10 one from Walmart, right? You're going to have to be careful. Don't do 2 times 20 and then divided by 18, because what it's going to end up doing is dividing your 20 by 18. It's not going to work out. So be careful that you're multiplying everything on the top and then dividing it by everything already multiplied together at the bottom. Oh yeah, I'm sorry. I didn't even look at that. 2 times, so it should be 2 times 1,000 times 20. Sorry, thank you. 18 and 60. So what should your final answer be? Our final answer should be in GTT per minute. What do you get? Okay, so how many sig figs? In 2.0, there's 2. In 18, there's 2. In 20, there's 1. So what should our answer be? What did you get in your calculator? Let me write that. What did you get in your calculator? 0.03. Okay, so now round that to 1 sig fig. 40. Why is it not 4? Right, you gotta, that 7 just turns into a 0, right? So be careful, be very careful. Okay, so let me erase this stuff that I put down here.
Can you show me how you get the significant figures?
Oh, sure. So let's circle in blue. So circle all of your values, right? Anything with a number in the problem. So the first one was 2.0. So I'm coming in because decimal's present. So I have 2 sig figs. Here decimal's absent. So I'm coming in this way. Still got 2 sig figs. In 20, present or absent? It's absent. There's no period. So come in this way, cross out your zeros. I have how many sig figs? 1. So you take the lowest number. Okay, how long would it take in hours to administer exactly 500 milliliters of fluid through an IV with a drop factor of 30 GTT per mil if the drip rate is 60 GTT per minute? Ooh. When do you go back and check on the patient? Right? How long is their IV supposed to go? So what do we want to start with? Okay, we have 500 milliliters. And if they say, how long would it take in hours to administer exactly 500 milliliters? I assume that that is a decimal present, right? So, but they don't do it here in the book. But trust me, if I want you to count that as 3 significant figures on an exam, I will give you the decimal place. Okay, so really that's 1 sig fig because they didn't put a decimal. Okay, so 50 mils. Now what am I going to do? Yeah, so I want to put milliliters on the bottom, and this is the relationship I'm going to use. So 30 GTT in 1 mil, that's right. So my milliliters cancel. I'm in GTT, but what do I want? I want, it's my goal, hours. Okay, so now I need to convert what? I need to get rid of GTT. So GTT is going to go on the bottom. What's going to go on the top? Minutes, because that's what I'm given here. I know my relationship here. So I have 60 GTT in 1 minute. So what cancels? GTT, I'm in minutes. Is that what I want to be in? No, golly. So minutes goes on the bottom. What goes on the top? Hours. How many minutes? In 1 hour. Okay. What do you get? What? Not 41. 4.17 hours. But really, how many sig figs does my answer? 1. So what should it be? 4 hours. Okay. So go check on your patient again after an hour, right? And their IV should be almost done. Okay. Like this is really applicable stuff. I feel like they throw it in really early, but it's really, really important. Okay. This one, I don't know if it's so applicable, but we'll go ahead and do it. So a medium-sized carrot. Oh, that goes perfectly with my joke today. A medium-sized carrot weighs 61 grams and contains 6 grams of carbohydrates. What percent of the carrot is carbohydrate? So you remember when we were doing these problems earlier in the chapter? And we said is the same thing as equals. Is equals, right? So how would I set this up? It's a percent of a whole, right? I want to know what percent of the carrot is carbohydrate. So I know I have 6 grams of carb, right? And that is what percent of the carrot? So it's X over 100 of the carrot. What's the carrot? 61 grams. So the carrot is the whole and the carb is the part, right? So all you have to do is solve for X. What do you get? What did you get in your calculator?
9.8.
Okay, so now I look at my sig figs. 61 has how many sig figs? 2. 6 has how many sig figs? 1. So it should be 9, not 9. That would be if you could round. 10%, right? Because you look behind the 9, that's an 8, and it rounds up. Good. Moving on to chapter 2. How much time we got? 10 minutes? We're a little bit behind. We're a little bit behind. It's okay. 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 We will get there. All right, y'all ready? Changing gears. So those dimensional analysis problems are probably what you're going to use the most from this class. And like we finished them on the third day. But if you need help with that, please ask. Please ask. Okay, so I think in the video I just skipped these because it's kind of nice to have them all together at once, and let's do it together. So what are the subatomic particles that are located inside of an atom? Now we're going to talk about really atoms, how they're organized, how they get together and do things. And so we're going to start really with radioactivity, which really has to do with the nucleus. But in the whole atom, what subatomic particles do we have? Proton. What's the symbol for proton? P plus. What else you got? Neutron. What's the symbol for neutron? N with a little zero. Okay. And what else? What do we use a symbol for? E minus. Okay. How does the mass of a proton compare to the mass of a neutron? The mass of a proton is what to the mass of a neutron? Equal, approximately equal. Not quite, but very, very close. How does the mass of an electron compare? It is a whole lot smaller. It is a whole lot smaller. So it's about, an electron is approximately 2,000 times smaller than the mass of a P plus. So the mass of an electron is about 2,000 times smaller. So vastly smaller, right? So if we want to say the approximate mass of a proton or the approximate mass of a neutron, what do we say that is? 1 atomic mass unit, and we abbreviate that AMU. So the mass of an electron would be 1/2000 of an AMU, right? Really, really, really tiny, really tiny. Okay, so when we talk about elements, right, there are certain things that we see on the periodic table. So when we look at any given square, look at carbon, for example, on the board or on your best friend. The little number in the corner here, and I think in the best friend, it's up on top, I think. What is that number? It's number 6, and we call that number the atomic number. What does that atomic number tell us? So B, the atomic number tells us it's equal to the number of what? Of, I heard it. Protons, right? Tells us the number of protons. What else does it tell you? And number of electrons in a neutral. That's very important. Neutral atom. If it is charged, that is a false statement. So only if that element is neutral, if that atom of that element is neutral. Okay, so look on the periodic table. What is the mass number of carbon? Is it on there? What's our mass number? It's not on there. That's one that's not on the periodic table. But a lot of times, if you're given a name like this, carbon 12, that 12 is the mass number. So what is the definition of the mass number? The number of protons plus the number of neutrons. So from the mass number, what can I determine? If I know I have carbon 12, I'm sitting with a periodic table. I can know my number of protons. How many protons does it have? 6. How many neutrons does it have? 6. How did you know that? You did 12 minus 6, right? Because the mass number is protons plus neutrons. So I can identify my number of neutrons from that. Okay. All right. C, the mass number minus the atomic number. What can we figure out? Number of neutrons. Good. Very good. Okay. Provide the name and atomic symbol of the element that has the following atomic number. 79. What is 79? AU, but that's not the name, that's the symbol. What's the name? It's a weird one. It's gold. It's gold. All right, 19. Got the weird ones to start with. What's 19? Potassium, and that is K. Now, if you have your best friend next to you, what's on the second page of your best friend? The first page is your periodic table. What's the next page? It's all the names spelled out. So if you don't know what a symbol means, you can go find the symbol and then find the name, okay? 82. What is 82? PB. What is PB? Lead. L-E-A-D, not L-E-D. Okay. 33. AS, but what is AS? Arsenic. 11. Sodium. All right. Okay. What is the mass number of a fluorine atom that contains 10 neutrons? So we have a fluorine atom, that's symbol F, contains 10 neutrons. Whenever we look at a symbol, right, we're going to put two numbers with that symbol, right? We're going to put an atomic number and a mass number. What's my mass number? How many? Mass number is number of what? Plus number of neutrons. So what is it? Protons, how many? 9 plus 10 gives me 19. Okay. All right. Let's see if we can get one more. Right? We end at 20. Right? Okay. Determine the number of protons, neutrons, and electrons in the following atoms. A helium atom. So helium is what symbol? He, and He has how many protons? 2. Okay, so a helium atom that has a mass number of 4. What am I going to do? Protons, neutrons, electrons. You just told me the protons, there are 2. A mass number of 4, a mass number is protons plus neutrons. So how many neutrons? 2. How many electrons? If it says it's an atom, then it must be neutral. If it's charged, we call it an ion. So in this case, the number of protons must equal to number of electrons. So how many? 2. Good. Okay, a carbon is C, that has a mass number of 14. So how many protons in carbon? 6. I just got that from the periodic table. So then 6 plus what is 14? 8. 8. Okay, and then how many electrons? Because it's it should say a carbon atom. It really should say a carbon atom. How many? 6. Okay, at least we got to start on chapter 2. We made some progress. Oh, I did want to tell y'all, if you get to the point where you're doing problems like 2.13 on the program, you have to use what are called stacked superscripts. So be careful that when you put these in, that the number that's on top is directly above the number that's not on bottom, not that they're like catty corner. So be careful with that when you're entering it into the online homework system. Yes, ma'am. Let me end the Zoom real quick. Anybody on Zoom got questions? I'm sorry, I put the chat all the way down. Okay, haven't heard from anybody, so I'm gonna go ahead and end the Zoom. Maybe I'm gonna end the Zoom.